going live. Hello. I am live now. Let me share the copy. Alright. I'm sharing it on the Discord. I was helping somebody. Uh, One of my dad's friends called them and they got a new TV and couldn't make cable come up. Uh, I think they're. I keep. Like, they sent me a picture and I was like, okay, that broad flat one. Where is it hooked up to? And they're like, the wall. I'm like, that's not it. That's no. Uh, so I was, and then they're like, well, somebody's coming over to hook it up for us. And I'm like, oh, all right, I gotta go. So yeah. So let us. Oh, somebody asked me. I'm gonna give it a minute for some people to show up. No, there's 4 of you. That's good enough. But somebody asked while I was on the phone about insurance. There's Grayson. Okay. How do I go about trying to find out what copays are and what insurance I have? I'm trying to set up an eye exam. Apprentices. Alright. Uh, and I will get to him a better answer in a bit. Alright. Wow. Lost some viewers. Alright. We are good to go. I didn't start as early as I was planning to. So let's do our starting now, and that should be long enough that if somebody was like fast forwarding, they would see it. Alright, let's get started. A blank is an electric device that uses electromagnets to change voltage from one level to another or to isolate one voltage from another. So that's a transformer. There's various reasons to use a transformer. Uh, One reason is to isolate voltage from one another. So if you have transformer, so you have power coming in, and this is the schematic drawing for a transformer. So you would have your power coming in over here and power coming out. You can see that there is no connection being made in the middle. So you are protected from something coming straight through. There is a disconnect. They will use transformers to isolate power from one spot to another, using things like hysteresis and things like that, because it's going to take a second for the transformer to actually catch up because of magnetic buildup and saturation and stuff. And you can prevent surges and things like that from happening using specialty transformers. Another thing that in a power block, which I don't have a good one, but I have one, in something like this, a uh, phone charger. This is my Amazon Fire plug. But in something like this, there's a transformer inside that isolates the power here from the power here. And there is no way for this to fail that you would get 120 volts coming out here. And that's a safety thing because one side's 5 volts, the other side's 120 volts. If you were just using resistors or something to drop the voltage down really low, you would be getting a ton of voltage. Or it could fail, like a resistor could blow out and you would get all the voltage out. But with a transformer, that can't happen. So inductance is the property of a device that causes it to store energy in a magnetic field. All electronics have some inductance, but it's usually negligible and something has to be built for inductance for it to actually use the inductance. Self-induction is what generates inductive reactance. That's where it induces a voltage back on itself. And we've kind of covered that in DC or AC theory. Yeah. Blank is the ability of an inductor in one circuit to induce a voltage in another circuit. That is mutual induction, because so if you had two pieces of Romex laying next to each other, they're going to induce voltages on each other. And that's always going to be true. Usually it's negligible, but there will be some induction back and forth. Two to one was the turns ratio of a transformer with a primary current of 31 amps and a secondary full load current of 62 amps. That is a 2 to 1 ratio. You could guess that it was a 1 to 2 ratio depending on how it's said, but is the primary. Oh, so uh, amperage actually goes down and voltage goes up in the transformer because the two sides will have the same so the two sides of the transformer. Oh, I could have left that drawing up. Oh well, let's draw it a little bit smaller. Okay, so the two sides will have the same power output. So let's say it's 200 watts. Well, this side will also have 200 watts. But let's say this 200 watts is 100 volts, 2 amps. Well, if it was a 2 to 1, this side would have 50 volts. Yeah, so for every 2 volts, you have 1 amp. Or for every 2 volts, you have 1 volt over here. That's not equals, that's slash. So if you had 50 volts on the other side, this is a 2 to 1, you would have 4 amps. It's still 200 watts on both sides, but the equation is different. It's funny, I kind of instinctively made it P is I and E. I made it like the formula. And maybe that's helpful having the formula written. Probably is. Alright. A transformer has a secondary voltage of 12 volts and a turns ratio of 10 to 1. Was the primary voltage. So, in this one, it's 10 to 1. This side is 12. So, the other side, so for every 1 volt over here, you have 10 volts on the primary. If you have 12 volts, well, that's times 10 is 120. Done. A blank is an extra electrical connection and a transformer coil. Okay, so this is a coil tap. Let me pull up a picture. Images. Okay, none of these. Technically, maybe that, but transformer. Let's put transformer coil taps. That's better. Let's find a good picture. I should get one of those eye tracking things so y'all can see what the hell I'm looking at. Okay, let's go back. Open image in new tab. So each of these different little nubs, that is called a coil tap. So what this does is it lets you go, because it's not 10 coils and 1 coil, it's like 10,000 coils to 1,000 coils. And let's say you're trying to go from 24, let's go 480,000 volts to 480 volts. Well, let's say you don't have exactly 480,000 volts coming in, but you still want to get 480 volts at the end. Well, you can change this 10,000 to 1,000 to 10,000 to 995, or 10,010. And that's going to adjust your voltage just a little bit, but help you get it dialed in better. And that's the purpose of coil taps, is so you can change just how many coils you have between the two sides to adjust your voltage just right. And that has, you'll learn a whole lot more about that in higher levels of transformer. Mostly what we're doing today is transformers theory, which I know it's first and second year is all about the theory and less about the actual putting the work in. But in third, fourth, and fifth year, you start getting into the actual putting the work in. Yeah, each one of these is a single-phase transformer, and this is a three-phase transformer. It's a picture of a three-phase transformer right here. Yeah. All right. Blank loss is power loss in a transformer due to the currents induced in the metal field structure from the changing magnetic field. Eddy current loss. So the higher your frequency, the higher your skin effect and eddy current losses are. We've kind of talked about eddy currents and skin effect already in previous lessons, but just a quick overview is the higher your frequency, the less of the conductor the uh, the current the electrons use. Man, everything's going off in my house right now. And sorry, give me a second. Refocus. Uh, the higher your eddy, the higher your frequency, the more your eddy currents will be, and it's a type of inefficiency that it mostly affects transformers. It happens everywhere, and mostly we as electricians don't need to worry about it, except in high frequency situations. But most everything that we have to deal with as construction electricians doesn't have anything to do with currents other or frequencies other than 60. But it does happen at higher frequencies, and it is a thing to pay attention to. Blank is the property of ferromagnetic materials where the magnetic induction of a coil lags the magnetic field that is charging the coil. Hysteresis. I think we talked about hysteresis already, so I'm just going to move on. Transformer mutual inductance is referred to as a coefficient of coupling. That's purely the two sides of the transformer do induce current on each other a little bit, and that's another inefficiency in a transformer. But it's at the manufacturing level, not anything that we deal with. Liquid immersed transformers are immersed in oil. Usually it's mineral oil or some oil like that. Mineral oil is non-conductive. So you could literally take sensitive electronics and dunk them in mineral oil, and they'd be fine. They'd be covered in oil. And there are some hazards with mineral oil. I think it's a weak solvent, I think. So some of your and this doesn't have to do really with transformers, because obviously whenever they create a liquid immersed transformer, they create it out of things that you don't need to worry about being immersed in oil, because it's made to be done that way. But if you can look up on YouTube different videos of people doing liquid immersed computers, where they just take the whole computer and dunk it in oil, like in a tank, like a fish tank, and it feels like the worst way to do it, the worst way to do a computer. Also, there's a wicking effect. Like whenever you have a wire come out of the oil will travel up the wire somehow. I don't know. I don't understand it, but the oil will come up the wire and get everywhere. So you have to pay attention to that too. The blank in a transformer is the difference between the hot spot maximum. So this is the temperature rise. It's how much the temperature rises. Page 29 for more information. Electrical power circuits must be insulated by bushings. Or they enter the transformer tank. Transformers are rated by their capacity in kilovolt amps. This should actually be voltamps. Watts and voltamps are basically the same, but there are some nuanced differences. Alright, and that is it. I don't think 15 minutes is enough to get through most of these lessons. Alright, just missing the one. Good job, everybody. Alright, transformer connections. I would recommend, in addition to doing this lesson, going into your homework and looking at some of the transformer connections there. I did make a special YouTube video on my channel about transformer connection drawings. Watch that in addition to this. Alright, go ahead and do this. Do not forget, between 11:30 and 2 o'clock, you need to go pick up your tests. So the 3 of you that are watching, make sure you get that done.